Hello.
Hello, sir.
Yeah, madam. Shall I start now with the formal introduction?
Okay.
Participants will be slowly joining, so I'll start with the session. Otherwise, it will become late for you to conclude also.
Okay.
Good afternoon, everyone. Today we have with us Mrs. Cini John. I'll just give a brief introduction of hers. Her career started with Department of Telecommunications on completion of BTech in Electrical Engineering. And after 7 years over there, she joined KSEB, the state power utility for the state of Kerala, and is still working over there. She has experience of over 15 years in the field of power transmission and presently working in renewable energy department for the last 5 years and is in charge of e-mobility projects in the state. With this brief introduction, I would request Cini John madam to take over and start the session. Ma'am.
Hello, good afternoon, sir. Good afternoon, all. Thank you for the nice introduction and thank you for inviting us to this program. Let's start the session on today's topic is electric vehicle charging standards. Okay, let's start this session.
Yes, ma'am.
Okay. Slide out a moment. Starting.
Just minimize the
next slide.
Okay.
Next slide.
Right side that minus sign.
Okay. Coming to, let's start with the EV, three methods of EV charging. There are generally three methods of EV charging. One is conductive charging, the second one is inductive charging, and the third one is battery swapping. First one is conductive charging. In conductive charging, it uses a direct contact between electric vehicle connector and the charge inlet. The cable can be fed from the standard electrical socket or charging station. There are basically two methods employed in EV charging station using conductive method, namely AC chargers and DC chargers. Then second method is inductive charging. Inductive charging is a technology which uses in which electricity is transferred through an air gap from one magnetic coil in the charger to a second magnetic coil fitted in the car. In this case, all we have to do is to park the vehicle in the right place so that the coils are aligned and the charging will begin. Here you can see that. And the third method is battery swapping. As all of us are aware, it is nothing but replacing the depleted battery of the electric vehicle with a charged one, just as we do in the case of LPG cylinders. A battery swapping or switching station is a place at which a vehicle's discharged battery or battery pack can be immediately swapped for a fully charged one, eliminating the delay involved in waiting for the vehicle's battery to charge. We know that the high upfront cost of electric vehicle is due to the high price of the battery pack, which constitutes approximately 40 to 60% of the value of the electric vehicle. Here we can note that in the case of battery swapping, the battery packs are separated from the vehicle and it's generally owned by the energy operators. Therefore, the end user will only need to pay whenever they swap the used battery with a charged one instantly. It is a promising charging option for two-wheelers and three-wheelers. Then coming to conductive charging, there are, as we have mentioned earlier, there are two methods. One is AC charging and the second one is DC charging. Here you can see how the AC charging is done. AC charger is commonly known as the onboard charger. It really is a converter. We know it converts AC to DC. We know that the vehicle battery needs DC power. In the case of AC charging, AC power is fed by the charger, and the onboard charger, which is present inside the vehicle, converts the power from AC to DC and then feeds into the car's battery. The EV manufacturers mostly stick to an upper limit of 32 amps or 7.2 kW for AC charging. This is due to the constraint, due to the space and weight, etc. of the converter, which is situated inside the vehicle. In the case of AC charging, the vehicle's charging speed depends on how fast this onboard system can receive the alternating current from the source. We'll see the main advantages of AC stations. One is that they are affordable and they are significantly smaller, and their installation is simpler, faster and less expensive. So, AC charging stations are also suitable for home installation and also for night charging. Then coming to DC charging. DC fast chargers operate at level 3 charging powers, that is more than 50 kW, and are designed to charge electric vehicles quickly with an electric output ranging between 50 kW to 350 kW. DC fast charging bypasses all the limitations of the onboard charger or the AC charger, and the required conversion, instead of providing DC power directly to the battery, charging speed has the potential to be greatly increased. Charging time here are dependent on the battery size and the output of the dispenser and other factors, but many vehicles are capable of getting an 80% charge in about under an hour using most currently available DC fast chargers. This DC fast charging is essential for high mileage, long distance driving and for large fleets. The main thing about DC charger is when the charging is on DC, the charger is outside and outside the vehicle, and there are not much constraints for the power transfer except for the limits of the battery. Then coming to the charger classifications. It's based on, there are 3 classifications. One is based on modes of charging, second is levels of charging, and then types of chargers. Coming to modes of charging. The modes of charging is based on the communication and control. As per IEC standard 61851 and IS standard 17017, there are 4 modes of EV charging defined. Out of this, first 3 are for AC charging and the 4th is for DC charging. As mentioned earlier, the modes are distinguished based on the communication and control associated with the charging equipment. Then coming to mode 1. It's a method for the connection of the electric vehicle to a standard socket outlet of an AC supply network using a cable and a plug. Here we should note 2 things. One is the maximum rated current in this case is only 16 ampere, and There is no communication between the electric vehicle and the charger. This is mode 1. And coming to mode 2, the difference is that there is semi-active communication between the electric vehicle and the charger, and it's provided in the cable, the connecting cable between the EV and the charger. The communication is semi-active. That is, the communication will not be there throughout charging. And the second thing is that the maximum rated current in this case is 32 amps instead of 16 amps in the mode 1. Coming to mode 3, there is control and communication throughout charging, and the control and communication is done by the charger itself. It's not provided in the cable. It's done in the charging station itself. And coming to last and fourth mode, it is DC charging. The first 3 modes are for AC charging and the fourth one is DC charging. So we know that control and communication will be throughout charging and the charger will be responsible with that. Then next classification is based on levels of charging. Levels of charging is basically it's based on the power capacity that can be transferred. Power levels that can be transferred. The Society of Automotive Engineers, SAE, J1772 defines the requirement for the EV charging station systems used in North America. The IEC has also adopted the SAE J1772 standard under IEC 621961 for the international implementation. The charging levels are defined based on the power distribution type, standards, and also maximum power. Now let's go on to various levels of charging. First one is AC level 1. Here, the input is single phase AC. The rated current is less than 16 amps. Charging load is less than 3.3 kW. Hence, the charging time will be around 8 to 9 hours. Duration is very high. Then coming to level 2, input is three phase or single phase. So the charging current, rated current is 63 amps or 32 amps respectively. The charging load is 43 kilowatt for 3 phase maximum and 7 kW for single phase maximum. Then the charging time reduces to 5 to 6 hours. Level 3 is DC fast charging. Here, charging load is always greater than 10 kW. Input is 3 phase AC. Ampere is 300, 400, 250 in that range. Then comes types of chargers. Depending upon the car brand and the country, the connector varies in size, shape, and pin configuration. One of the main reasons is the difference in AC voltage and frequency around the world. We know that in North America, it is single phase 240 volt, 60 hertz. But in Europe, it is 230 volt, 60 hertz and 400 volt, 50 hertz. So due to these differences in voltage, number of phases and frequency, there exist differences in the charges between the two regions. That is the main reason. So in various regions across the globe, various pin configurations are used or types of chargers are used. Here we can see in Japan, J1772 or type 1 is used for AC, and for DC charging, Shadamo is used. In America, for AC charging, type 1, the same plug is used, J1772 as per SAE standard, type 1. And for DC, CCS1, that is the combined charging system, type 1 is used. And in Europe and rest of the world, for AC charging, a type 2 socket, which is commonly referred to as minikis, is used. And for DC charging, it is CCS2, combined charging system 2. And finally, in China, they have their own standard, which is known as GB/T for AC as well as DC. We'll have a look at all the pin configurations one by one. The first standard is J1772 type 1. SAE J1772 or as per IEC standard, it is 62196 type 1, which is also known as J plug. It's a North American standard for electrical connectors for electric vehicles maintained by the SAE International. It covers the general physical, electrical, communication protocol and performance requirements for the electric vehicle conductive charging system and coupler. It combines coming to the next one is this is a J1772 type 1, and this is a combined charging system CCS1. The combined charging system or CCS connector, which is also referred to as combo, are integrated connectors for both AC and DC charging. It is derived from type 1 and type 2 connectors for AC chargers by adding 2 extra pins at the bottom for a power transfer, DC power transfer. The vehicle connectors derived from AC type 1 and type 2 are respectively called combo 1 and combo 2. Here you can see the difference. This is a type 1 plug, and the CCS1, the difference is that it has 2 fat pins at the bottom for the DC charging. So it's a combo or combined charging system, and it is CCS type 1. And similarly, this is the AC type 2 connector, which is a European standard. And when it's integrated with the DC charging pins at the bottom for DC power transfer, the 2 big pins here, you can see it's for DC transfer. So when the AC type 2 is combined with DC, it becomes CCS2. This CCS charger, combined charging system, charger is suitable for variety of vehicles like BMW, Mercedes, Volkswagen, Audi, Porsche, etc. And this is the Japanese standard for DC charging. This is called SHADAMO. This connector is used for Japanese vehicles, namely Nissan, Mitsubishi, Toyota, etc. Coming to Chinese standard, it is called GB Bharti. It is used for all Chinese vehicles. And there is one more standard. It is called Tesla Supercharger. It is a 480 volt DC fast charging technology built in American vehicle manufacturer Tesla for their electrical cars. Here we can note that Tesla cars can be charged using other fast chargers with the help of an adapter supplied by the company. However, cars other than Tesla cannot be charged at Tesla stations. This is a Tesla supercharging station. So, summarizing the above connectors, you can see that in the America for AC charging, SAE J1772 standard type 1 plug is used, and for DC charging, CCS1 charger is used. And for in Europe and rest of the world, it is type 2 or Menikis plug for the AC charging, and CCS2 or combined charging system 2 for DC charging. In Japan, the similar plug is used. Type 1 AC plug is used for AC charging, and SHADAMO connector is used for DC. Then coming to communication protocols. When the charging station and electric vehicles are connected, the charge controller in the station communicates with the EV. In this communication, information regarding the connectivity, fault condition, current limits, etc. are exchanged between the EV and the charger. The power control unit appropriately adjusts the voltage and current of the DC converter to control the charging power delivered to the battery. The power control unit in turn gets inputs from the battery management system or BMS of the vehicle for controlling the battery charging. Regarding communication, we should note that there is two levels of communication here. One is between the electric vehicle and the charging station, and the other is from the charging station to the back end. Here, the communication between the electric vehicle and charging station happens in two methods. One is control area network, or commonly known as CAN, and the second is power line communication, which is commonly known as PLC. That is for EV to charger communication. And for storing this data of transactions happening in the charger to a backend server, we are using OCPP, that is Open Charge Point Protocol. For this communication. The Open Charge Point Protocol is an application protocol for communication between the electric vehicle charging station and the central management system. It's an international open source vendor independent standard which is available for free. The version of the protocol was developed in 2009 for the EV infrastructure market and is supported today by many large players in the electric vehicle industry, such as utilities, charging station manufacturers, charge point operators, and back office software suppliers. As such, this OCPP is designed to be vendor independent, thereby providing the opportunity for infrastructure operators in choosing the EV charging stations and for vendors to supply EV charging stations to any infrastructure operator. Similar to many IoT protocols, OCPP describes the messages that charging station and IT backend send to each other to authenticate new EV users, track energy meter values, or give charging commands. It will support charge point information. It will also support authorizing charging sessions, various tariffs, reservation, roaming, then handling registrations, and it's also suitable for smart charging environment. Initially, it was OCPP 1.5 protocol. Then it was upgraded to 1.6, and now it is OCPP 2. Then let's have a look at the connector pin configuration. As we have already seen, the connectors have big fat pins for power transfer and small pins for control and communication. Here we can see there are 5 pins, 3 big pins and 2 small pins. The 3 big pins are for power transfer. This is line 1, it's line 2 and ground. And here's a control pilot, small pin, which is called a control pilot. It is referred as CP. And here is a proximity pilot, which is referred as PP. The purpose of proximity pilot is to ensure that the vehicle does not move while it's being charged. It's a safety mechanism. That is, this pin monitors the connection between the charger and the vehicle. It is called proximity pilot. And there is one more pin. It is control pilot, which actually controls the charging rate. Control pilot sets the actual charging current and thus controls the speed of charging. Here we can see all the other connectors. Here you can see the GBT connector. The two fat pins are for DC power transfer. This is DC positive and this is DC negative. These are proximity pilots. These are for CAN LH and CAN L. That means the communication between electric vehicle and charging station is through control area network or CAN protocol in the GBT connector. And these are the pins responsible for that. Here's the auxiliary power pins and also the protective earth. Coming to CCS configuration, these are the two big pins for DC power transfer. This is the control pilot. This is the proximity pilot. And this is the protective earth. In CCS, the communication protocol is PLC, power line communication, between electric vehicle and charging station. Coming to SHADEMO, this is the power transfer pins, DC positive and DC negative. There are some additional pins, additional control for charge, start and stop. This is for charge enabled or disabled. This is proximity pilot. And here also communication between charger and EV is through control area network, CAN protocol. These are the two pins, control pins for that. And the last one, Tesla supercharger. These are the power pins. And these are the control pilot pins. This is the proximity pilot pin. This is for a proprietary charger for Tesla, only for Tesla cars. Here we can see the connectors as well as the vehicle inlets. This is the SHADEMO connector. This is the vehicle inlet for corresponding vehicle inlet. This is GBT. This is the corresponding vehicle inlet. Similarly, this is the combo one used in US. This is the CCS type 1 and this is the CCS type 2 or combo 2 used in other parts of the world. Coming to the charging standards of India, Department of Heavy Industry is the nodal department for the FAME India scheme. That is faster adoption of manufacture of electric vehicles. That is a FAME scheme by Government of India. The nodal department for the scheme is Department of Heavy Industry. So they are responsible for standardization of protocol for EV charging stations. DHI has published Bharat Public EV Charger Specifications on 21st November 2017. Then about public charging standard of India. One is Bharat AC 001. Capacity is 10 kilowatt. Here the power input is 3-phase 15 volt AC. There are 3 outputs, each of 3.3 kW. Connector is IEC 60309. Can deliver a maximum 15 amps current at 3.3 kW. And it can power 3 vehicles simultaneously. Basically, it's a low power charger, and so there is no communication between EV and EVSE. the communication protocol for the data transfer from the charging station. It is OCPP 1.5 or higher. Then coming to next standard is Bharat DC001. Here the input is 3-phase 15 volt AC. Power output is maximum 15 kW. This is the output. Output is DC. It can deliver at a power at voltages 48 volt or 60 volt or 72 volt depending on the vehicle battery configuration. Here the number of outputs is only 1. The connector is GBT 20234.3. It is a slightly modified version of GBT that India has adopted. It can deliver a maximum of 200 amps charging current at 15 kW power to the vehicle's battery. Here, the communication protocol between the EV and the EV supply equipment, that is nothing but EV charger, is control area network or CAN. And EVSC CMS protocol. CMS means Central Management System. Communication protocol is OCPP 1.5 or higher. OCPP here open means it's applicable for all. Then coming to chargers for high voltage EVs. Bharat chargers, that is AC001 and DC001. They can be used to charge all the two-wheelers, three-wheelers, as well as Tata, Tigor, Mahindra, Everito, E2 Plus, etc. available in India. However, India is yet to develop its own EV charging standards for high voltage charging technology. So it has adopted CS2 for that purpose. So IS 17017 Part 1 recommends CCS2 and SHADAMO protocols for this purpose, for high voltage electric vehicles charging. Then the electric vehicle charging infrastructure certifying agency is ARAI, that is the Automotive Research Association of India, established in 1966. ARAI helps the government in preparation of safety and emission roadmap and formulation of standards. It also does the R&D work for the automotive and component industry. Coming to setting up of PCs, DHI and MOP have issued guidelines for setting up of public charging stations. As per these guidelines, installation of public charging station is a delicensed activity. No license is required. Anybody can start a public charging station. Only thing that he should obtain all the permission and conformance to protocols and standards. And he should apply for connectivity to the DISCOM, distribution company. All the minimum requirements for setting up of charging stations are issued by Government of India. Then coming to KSEB, Kerala State Electricity Board. We are the state power utility for the state of Kerala, and Government of Kerala has issued EV policy. As per that, KSEB is responsible for electric charging stations. It's a nodal agency for electric charging stations. And KSEB is setting up a network of charging stations across the state. KSEB is intending to set up around 250 stations. The pilot project of 6 stations are already completed, and 56 stations, the work has already started, and many other projects are in pipeline. This is the ongoing projects. Thank you.
I take questions from participants. Hello, participants can ask the question in chat box or.
Hello. Hello. Participants can ask questions.
Attendee number.
Hello.
Yes, sir. Yeah, attendee number 052. You can unmute and speak.
Hello. Am I audible?
Yeah.
Am I audible?
Yes, you can ask the question.
Good morning. Yes, good morning, madam. It was a nice presentation, short presentation regarding the standards. My question is that, the electrical vehicles are going to need the charging stations.
Yeah.
Charging stations. So are these charging stations will be established by government or private agencies? What is the things which is going to happen in India?
It is as per Government of India guidelines, say delicensed activity. So anybody who wants to set up a public charging station can do that as per the guidelines of government and also the state government guidelines of corresponding state.
Cost? So whether the charging system will be different for different vehicles, or in the same charging station, you can just charge your car, you can charge the scooter, you can charge the that is a multi-wheel vehicle. What will be that? Will be the that is charging system different for different vehicles?
Yeah, the charging system is different for different vehicles.
What will be the general cost of if you want to set up? if I got to say land and on the highway, and if I got that is set up the charging station, what would be the minimum cost needed for that?
My colleague, Mr. Sajin, is joining the panel for answering.
Hello, can you hear me? Hello?
Yes.
Hello?
Yes.
You can hear me now? Okay. The question is, it's like, how can you set up a charging station, and for different vehicles, how will be the charging station look like, and what will be the financial implication on that? Is it, am I correct?
Yes, sure, sir.
Okay, the first thing is when you set up a charging station, you can as Madam said earlier, it's a delicensed activity. Anybody can set up a charging station. So, as per Ministry of Power guidelines for electric vehicle charging infrastructure, like we have, it is mentioned clearly what kind of charges you need to put for 2-wheelers, 3-wheelers, and 4-wheelers. When it comes to higher, like more than 4-wheelers, like the trucks and buses, like that, they have a different set of standards also there. So it's been well defined. So how can you start a charging station? As in the presentation, Madam already discussed that there are different type of charges. So when it comes to a vehicle also, there will be a different kind of charges when it comes to fast charging. Like you're seeing in Tata Nexon is there. So they are using a CCS2 protocol. When it comes to this Tata Tigor, their own vehicle, they are using GBT standard. So when you set up a charging station, so depending upon the mobility there in your city or the place, so you can put up charging stations like that. So for 2-wheelers and 3-wheelers, you don't need a DC fast charger. A 16 ampere plug will be sufficient for a 3-wheeler, an e-auto. So it won't be a difficulty. You can make it anytime. But when it comes to fast charge only, this cost implication is there. So as you said about the cost, DC fast chargers like GBT, it may cost around like 2 lakhs is the base price I'm talking about for a 15 kW. When it comes to DC fast chargers like CCS or Shademo, it will be like 50 kW minimum that you need to put. So it will be costlier, like 7 lakhs above it will be there. You were saying something?
So that is a cost. Okay, that's a cost. But when it is going to be feasible, what do you think? When it is going to be feasible to just have the charging station?
Sorry.
How long?
I don't.
What I say. How long will it take to set up the power? We can find this charging station across India. If I just have a car, but see, if I want to roam in India, I need to have the charging stations across the cities.
Yeah. Actually, government
is there a time setup India has got?
Yeah. You were asking whether you can travel around India with an electric vehicle simply. That's it, right?
Yes.
So the thing is, like all states are setting up charging stations now, and the Government of India, Department of Heavy Industries, FAME2 scheme, they have invited expression of interest for setting up charging stations across express highways and major highways across the country. So there is a map which is also available in Department of Heavy Industries website, where you can see they are going to set up a EV charging infrastructure network throughout the country. Almost all states are included in that map, where at least within 25 kilometers range, you will have at least one charging station. It will be set up on that scheme itself. Apart from that, also there are like some major cities have been selected by DHI in FAME scheme that the setting up of charging stations are going on. In Kerala, we have already set up 6 DC fast charging stations, and we are on the verge of setting up 56
This is from
more.
The government side. Sir, we are talking up from the government side. This from the government side, no?
Yeah.
Government.
As an initiative to this industry, government is putting a lot of efforts, and the private partners are also come and join anytime. They are free to do so. There are many charging stations are setting up across the country by many private players. So the numbers are increasing day by day.
What will be then? We can see in some next 2 to 3 years or 5 years. we'll have charging station all across.
Yeah, obviously. Within 5 years, you can roam around in an electric vehicle almost freely, because abundant number of charging stations will be available. By 2021, the FAME 2 scheme will come to an end. By that time, at least major cities will be equipped with charging stations. And the cities like Delhi, they are like a very strong policy, EV policy they are following, with like within 3 km radius there will be a charging station within 2 years. Like that, almost all districts and all states will have a charging network within 5 years. And 2030, by 10 more years, like there is an expectation of like 30% penetration of total number of vehicles. Out of the existing petroleum vehicles, almost 30% will be electric vehicles. By that time, the charging network will be very strong. So you can expect within 5 years, it will be like a strong network will be there, hopefully. And the price of vehicles will also come down. I hope you understand. You clear?
Yes.
Okay.
Clear, ekdam clear. Thank you. I am a faculty here in Chandrapur, Rajiv Gandhi College of Engineering, Research and Technology. Chandrapur.
Okay. What was your name, sir?
Huh?
What was your name? I couldn't get your name.
Win Potdukhe.
Okay. Thank you.
Thank you, sir.
Thank you.
Yeah, any other participant would like to ask question, kindly put on in the chat box or just raise your hand so that I can unmute you. Yeah, ma'am, I think there are no further questions. If anybody has question, I'll pass it on to you so that we can just provide the reply to the participant.
Okay,
At present, we are not having any questions. Yes, ma'am. Yeah. Hello, can you hear me?
Yes.
So, if you permit, we'll just close down this session then.
Okay.
Yeah. Okay, fine.
Okay, thank you.
Yeah,
for
formally,
giving us
I would like. Yeah. Hello, madam. Yes, you're saying something.
Thank you for giving us an opportunity. Thank you.
Yeah. In fact, I should thank you for coming over here and taking the lecture, sparing out your valuable time and sharing your knowledge with the participants, because over here we are sitting in FDP, all the participants over here to gain knowledge, and you shared your deep knowledge in the area. So we would like to thank you on behalf of Department of Mechanical Engineering, Father C. Rodrigues Institute of Technology, for accepting our invitation and delivering the lecture. Thank you very much, madam.
Okay, thank you.
Yeah, so all the participants, the feedback link would be shortly posted on the WhatsApp group. The last session for this FDP would be starting on its allotted time, that is at 2:30 p.m. And from 4 p.m. onwards, we would be having a valedictory session. It would be I would say a formal informal session where I am expecting, I would be opening up everybody. So I am expecting people to switch on their video, share their feedback, share their thoughts with us. It was really nice that every one of you were with us during this entire event. So definitely we would like to hear from you, because since the past day, I was the only person who has been continuously speaking. So yes, I would like to hear from you. We would love to hear from you all. So during that session, make it a point so that you can switch on your video when you are speaking, so that everybody can see you and share your thoughts and share your feedback. Thank you all very much. Meet you all at 2:30 for the last session. Thank you once again. I am closing this now.